Okay. Welcome to today's seminar. My name is Beth Mashesky. I'm a research specialist at the Illinois Sustainable Technology Center and co-organizer of the seminars. Our next seminar is on November 30th, discussing per and polyfluoroalkyl substances in the environment, presented by Erica McKenzie, assistant professor in civil and environmental engineering at Temple University in Pennsylvania. I'll ask everyone in our audience to please silence or turn off electronic devices as we are recording this webinar. Also, we will hold all questions until the end of the presentation, at which time I will come around with a microphone so that those online can hear your question. For those viewing online, you can type in your question at any time and we'll answer those at the end as well. And with that, I'm very pleased to introduce today's speaker, Sudhir Brahmbhatt. Sudhir is president of the Technology Services Incorporated, which is based in St. Louis, Missouri. He has a wealth of knowledge in industrial gas applications for environmental, chemical, pharma, biotechnical, and medical industries, and has more than 25 patents for inventions in these areas. His industrial experience involve Exxon, Air Products, Mesher Gresham, and Air Liquide, with over 35 years of experience in this industry. He has authored papers in chemical engineering, ceramics engineering, Cryogas International, Gas World, and American Institute for Chemical Engineering magazine, and was also interviewed by Cryogas International. He continues to be a consultant for a wide range of industries, including top industrial gas manufacturers, chemical companies, and universities. Please join me in welcoming Sudhir.
Thank you, Beth. My today's presentation is going to be more on use of industrial gases in the aqua industry, water industry, and I'll touch on several things. And if there's an interest to know more, please let me know, and I'll try my best to answer your questions. As Beth mentioned, these are industries and these are applications, the services, what my company does. And we are based in St. Louis, Missouri. Glencoe is close to Chesterfield, Missouri. You can find all information on the website if you're interested. I want to, let's quickly focus on the wastewater treatment area initially. You can see that oxygen is an inevitable part of wastewater industry. Now, first question comes out of the oxygen. How is it made? How is it available? Just quickly want to go through as to what this is. You may use the term called ASU, air separation unit. The way the unit works is you have a, you take the air, clean air up, go through compression stage, and there's something called Joule-Thomson effect. When you compress the air and expand, it cools down. And that's the principle used in this production method. This is the column, distillation column, where you have nitrogen, oxygen, argon coming out. Again, it's a function of the boiling point of these gases. And if they're looking at selling this liquid oxygen, liquid nitrogen, means going from their manufacturing places to a lot of other places, they use liquid products. So they basically compress nitrogen, oxygen, and you may see on the road these big trailers going on. They use the liquid oxygen, liquid nitrogen, liquid carbon dioxide, and all those gases, they are liquefied. On average, you can see that when they refer the term A100 for ASU, air separation unit, that means you're making 100 tons per day of oxygen, 300 tons per day of nitrogen. And when they say liquid product, L200, that's a 200 tons per day of liquid products. That's what they refer. This is what industry norm is. This is what air separation it looks like. These are distillation columns. And then you have product once it's produced, you hold it in the liquid form and then ship it to the different uses. Most of the liquid phase reactions, when you look at wherever you need oxygen as a reactant in the liquid phase, this is what you're going to see. Water plus air. Theoretically, if you look at thermodynamic law, and the ambient condition, atmospheric pressure, and 56 degrees Fahrenheit temperature, you're going to dissolve maximum 8 parts per million of oxygen in the liquid phase. And that's what only matters, that 8% is what matters for the liquid phase reaction. Now, when you use pure oxygen, I want you to remember this part because it's going to play a very important role. When you use pure oxygen, you can see more than 5 times oxygen is dissolved in the liquid phase. That's why a lot of industries are using pure oxygen in their liquid phase reactions. Now, if you increase the pressure, this was ambient condition. So if you use pressure, you can increase the pressure 100 pounds, you're looking at more than 100 parts per million of oxygen in the process. It's a very simple example. If you look at oxygen to water they sell in the market, it's a bottles. And when they make it, they make under pressure, higher than atmospheric pressure. So you have a lot of oxygen in the bottle. But then when you open it, it's ambient pressure, so you lose most of oxygen which is in there. And so even though it's called oxygen in water, you don't have that benefit of having more oxygen, drinking oxygen. And there are a lot of benefits, by the way, high oxygenated water system. When you look at here, high DO level means high reaction, allowing higher production. We'll talk about this. Most of the applications are fish farming, fermentation for biotech industry, pharmaceutical industry, wastewater treatment, liquid phase chemical reactions. Almost all those places. I myself have done a lot of work in these areas, and I have patents in those areas too. This, if you look at the graphical view of that, what we just discussed, this is at atmospheric pressure and 60 Fahrenheit. You can look at oxygen concentration, ppm versus pressure. Increasing pressure, you can see higher dissolved oxygen level. Dissolved oxygen is generally referred to DO, by the way. And if you have atmospheric pressure, then you can look at the function of temperature. Higher the temperature, lower the oxygen concentration, lower the DO level in the liquid phase. Why pure oxygen? Saturation of oxygen in water is 5 times more when you use pure oxygen. Air has only 21% oxygen, and as you know, the total pressure is a function of partial pressure of component A, B, C, and D, whatever components you have it, and that's what reduces the partial pressure of oxygen to lower level. That's why you get 8 ppm. With increased oxygen supply, it's possible to increase the mixed liquor. Those who are in the wastewater treatment area, they will know the term in the aerator basin, and in fact, you will see some numbers that you have significant increase in mixed liquor, a volatile suspended solid. You're going to find that when you use pure oxygen. Now, this is another interesting aspect. Total gas flow through the wastewater with pure oxygen is 12 to 100 times lower than air. You realize what it means as to by having a lot less inert, lot less volatile organic chemicals coming out of the wastewater. And that's why oxygen is a preferred approach in the industry. These are some of the technical terms as to how you check the efficiency of oxygen. The most critical part is most critical part of what you look at here as to what the factors affects the oxygen utilization in the wastewater area. Depth of water, how deep you are putting the oxygen system, water temperature, flow rate of the water, oxygen concentration, and targeted. When you look at the efficiency of oxygen, this is just a simple calculation to show you that per meter or per every 3 foot, you have 16% oxygen utilization. So you can calculate from there, close to 90 to 100% oxygen utilization. You can easily calculate as though you're looking at 10 to 12 feet depth. That's what you're looking at where you want to use oxygen. These are comparison in the market. You have a system what I refer to as Biox. This is the hose that has, it's made up of EPDM plastic material. It has a less than 10 micron size holes here. And interestingly, when you use that in a use, the holes open up, has a flapper on. And when you stop using oxygen, the flapper closes. So this hose does not require any maintenance. In Europe, they have used widely for 15, 20 years. The quality stays the same. It's a significant impact on efficiency and also maintenance part. You don't have to replace this. It works great. So that's the bioexhaust system. This is air diffuser system. You might have heard that term, and surface aerators. Look at the oxygen transfer efficiency. Huge change. Look at the transfer rate per kilowatt hour. This was calculated because you have already oxygen made, in the air separation unit, and these are an air diffuser. Look at mixed liquor volatile suspended solid, as we mentioned before, and total gas flow. Significant difference. These are actual data, by the way, from the plant, okay? And you can calculate, you can see this information too. And so this, again, we saw the chart before. Biosystem, what you look at a system like this, it depends on the depth and the temperature, both are important parameters, depth and the temperature and the flow. And also, demand is highest in the warm temperature when efficiency is lowest. This is, I referred to a few minutes ago, as to depth is very critical in the efficiency of oxygen transfer in the liquid phase. These are some SOTE, that's standard oxygen transfer efficiencies. You can look at it, oxygen flow and efficiencies. Lower the flow, much better efficiency because you have bubble size, 10 micron size. Lower the bubble size, more the surface area, easier it is to dissolve. And also you're looking at bubble surface doubles per unit volume and diameter is halved. This is a very important critical parameter here. And deviations are source of the lower pressure. People use air diffusion in the industry over a certain period of time. Air diffusers, those membranes, holes, they open up. As bubble size gets bigger, you lose efficiency. Here, you don't expect anything to happen like that. This is the comparison of various applications in the wastewater treatment area, how they're done. Investment, extremely low. Aerators is very high. Efficiency, very high. Power consumption, there is no electricity involved here, by the way. When you supply oxygen, you have a tank on site. That tank holds liquid oxygen. You vaporize the oxygen. Oxygen vaporizes from liquid to gaseous phase close to 600 times to 700 times. Now you have pressurized oxygen. Then you use that pressurized oxygen, go into the tubes, and it does what you have to do it. In these places, there's nothing like, in these places, there is nothing like that. There is a power consumption here because you have rotating devices there. Same thing in aerators also. Maintenance, as I mentioned, significantly low. And there are different maintenance of flexibility again. Here you have ability to adjust the oxygen flow, to adjust DO level, depending on the needs. You have a heavy BOD requirement, biological oxygen demand, COD, chemical oxygen demand, and you can adjust your oxygen flow to get the desired DO level and make sure you don't have any anaerobic condition. And these are some of the parameters. We just to summarize those: low investment, high oxygen efficiency, no energy consumption here. At the use point, there's no energy consumption. Easy to operate, maintenance free, immediately ready for startup, high availability, noiseless, no other problem. When you pass through some wastewater treatment plant, you will see a lot of odors. What that indicates is it's an anaerobic condition happening there. You don't have enough oxygen. Dissolved oxygen level is low. I was in Kansas City last week, and I was passing through a highway. It was terrible smell. So we went to the wastewater treatment plant and told them what's going on there. And we learned a lot from that. So this is something interesting. Whenever you see the odor problem, now we can tell that to say, hey, by the way, it's anaerobic condition. DO is not enough. That's all it comes down to me. This is another interesting approach. When we came to, when you start talking about the smell, normally in the wastewater treatment plant, you have a collection basin. Water comes from all different areas, industry, homes, and all these different areas. It comes at one point, and that is a collection basin. Now, you will see that in this area, it's very easy to go to anaerobic condition, means deficiency of oxygen. And this, most of the time, smell comes from this area. So one of the patents that I had in 2001 was basically put oxygen in that basin and maintain that positive level of dissolved oxygen. Smell went away, totally went away. And the funny thing was, at this particular facility, it is in the middle of residential area. And before they had problem where they would resident, neighbors will call, what's going on with your plant? How come it smells so bad? And they were going to do major expansion. We were called in, and we talked to the system, and we put the system, and now they got so much used to that if there's a smell again, they say, did you shut that oxygen down? So these are neighbors, and they're telling that make sure the oxygen, that's what they were telling. So I think it shows a very simple solution, simple approach. Other alternatives that cost quite a few millions of dollars. This is a very simple approach. It's even less than $1 million you're talking about. Depends on the size of the system and things like that. This is what you saw for this system. This is actual installation. This is one of the companies where you see that you have a recirculating pump, and this recirculating pump, oxygen is injected into the pump. It's diffused in the water, and all the smells and everything went away. This is one of the plants, huge plant. You don't see any aerators here. These are basically all with biox host system, all with this system. 15, 20 years, no maintenance, nothing. And I personally have seen this. This is in Germany, and now US, we have also a number of operations here. So this was drawing on that. As we just saw, 3 approaches: biox host system, this is oxidator, and this is a supplying liquid, how they're supplying liquid oxygen to the system. When you use this and put this hose into the water and supply pure oxygen or air, you can see bubble size. Depends on the flow of oxygen or air, you're going to control the bubble size. And smaller the bubble size, easier it is, and for the gas, oxygen, or air to dissolve. Typically, when you look at that system, you go through evaluation process, and you find out as to what's needed and for the system and things like that. When you look at the biox host system, depending on the flow and oxygen requirement, you have a framework. You put those frames in the water, stop the aerators, and put oxygen through that. And that works great. Advantage of wastewater oxygen used in wastewater treatment plant, you're looking at significantly reduced dripping and foaming. This is very critical part. As you see with aerators, you want to get more oxygen in the liquid, you're going to put more air, more air, more air. Same thing with the fermentation, the other processes too. When you put more air, you're putting a lot of inert, a lot of nitrogen. When you put a lot of nitrogen there, it's going to foam up. It's going to create the foam because you have a lot of turbulence. And you're going to have volatile organics material which in there, it's going to come with nitrogen. And that's referred as a VOC. When you use oxygen, as you saw before, you reduce the total flow of air, total flow of oxygen going into the system. When you do that, you're directly impacting. This is no-no. When you have a high VOC, it is a problem to the community. And you want to reduce as much as you can. So EPA will tell them to control the VOC level, and you have to do something. This becomes a very important tool. Oxygen becomes an important tool for control of VOC. Improve sludge handling, reduce plant operating costs, reduce electric use. Now you saw that you don't need any electricity to supply DO. When they have an outage of electricity, the system is still working, unlike what they have today. Interesting part, now we saw the basic principle, how oxygen is used in the liquid phase. These are actual installation. Here is a fish. If you're familiar with that, normally, you're looking at density of close to 100 kilogram per cubic meter. And when you have a large quantity of fish in area, when you feed them, they're really running around. Why are they running around? The primary reason of running around, they're looking for oxygen. The gills open up, they put air through the mouth, and they separate oxygen through the membrane and get oxygen for consumption purpose. Now, we put pure oxygen in the system, and we found that dissolved oxygen was sufficient, and fish was extremely happy. They had plenty of oxygen available, so they're getting fatter and fatter. They're probably, their weight was increasing big time, and I'll show you numbers in a minute. And that was a big impact on on a fish farming too. Benefits in fish farming, desired DO level. It's between 12 midnight to 4 a.m. That's the big time fish is running around and looking for oxygen. And when we did that, we reduced the fish inventory loss. They normally use what they call paddle wheeler or tractor to supply oxygen or supply oxygen through air. When we did pure oxygen, they didn't need anything like that. When you do that oxygen, you saw the power saving because you don't need electricity. Capital investment tractors not needed, and basically there was no need for any tractor or anything like this. These are intangibles. Well, you are looking at the higher DO level, healthy fish. That's another one too. They stay healthy because they got plenty of oxygen, what they needed. Better food conversion ratio, resulting in improved efficiency in food use. Faster fish growth, as I mentioned to you before about ability to hold fish at one spot and control the pond. Fish try to be in one place. If there is oxygen available there, they'll go, all of them will go there. So significant reduction on DO there. If you don't have proper oxygen, they will starve to death. Much higher population density, reduced maintenance cost for paddle wheelers, reduced fish loss during soaking, or high temperature due to DO level. Again, a lot of things depend on DO level, and you can see with pure oxygen injected into the system, we were able to overcome that. There are some patents related to those areas. These are environmental industry patents. This is oxygenation water, oxygenating water. There are some other areas we have worked on. High temperature application, again, there are some of the patents also. Other aspect is pH level. In the wastewater or the water stream, what you're looking at is to CO2 helps you to control pH level. Normally, the approach what they take is use acid, sulfuric acid or hydrochloric acid. That's a very strong acid. It comes with safety aspect and things like that. When you use CO2 with the water, it makes a weak acid, carbonic acid. And this CO2 produces pH value simply by injecting into the system. And if you look at the reduction, change in the pH value, what you take hydrochloric acid and carbonic acid, it runs a parallel, similar approach on that. But it's a lot safer to handle, easier to work with. They are less prone to overshoot the pH, resulting in low pH excursion compared to strong mineral acids. Industry uses this approach also. So you can look at when you use a strong acid, like hydrochloric acid, nitric acid, sulfuric acid, all of these things. When you overshoot the pH by putting more sulfuric acid in case you made a mistake, then you're running into the pH level issues. Handling, personal property, personal PPE tools, the safety tools, risk of employees' exposure to burn, routine replacing acid pumps. These are standard in the industry, what happens when you use a strong acid. When you use the CO2 for pH control, there is no overshooting because it's a very weak acid. No operator handling or risk. It's directly injected into the system. Pressure is already there, so you don't have to worry about the pump or anything. No additional maintenance costs associated with acid. And CO2 cost per year. If you look at these two, there's a big difference. Impact, eliminate notice of violations and fine, because if you don't meet the requirement, EPA fines you big time. And you basically are eliminating the need for that. Lost time accident liability issues, reduced maintenance, and direct cost saving. These are benefits when you go with using CO2 for pH control. This is a system where they're using CO2 for pH control. Lower pH of an effluent stream prior to discharge. And these are areas where you find that CO2 being used, food industry, to clean tank, and chemical industry when chemically high effluent pH value, facility with high pH value, pulp and paper process water because it's an alkaline solution, textile manufacturing, effluent wastewater, concrete or mining operations with lime and discharge. These are potential applications for CO2 in the pH control. Drinking water, that's another area. As to how to sterilize the water or how to make the water compatible for consumption purpose. Ozone is used frequently. I know in third world country, other countries, this is a big deal, as to try to provide them clean water. Ozone is, again, it could be generated on site. All it needs is oxygen and some of the equipment, which allows you to convert O2 into O3 ozone. And ozone kills organisms, the sterilizing agent also kills organisms, things like that. That's used in industry too. Now, a few other things I want to touch on. This is all on oxygen, and it'll open for questions in a few minutes. But here is something interesting what Technology Services Incorporated has developed. This is unit. This is the wrench. You're seeing this. It's basically, the video will tell you a lot more about it. So let's go to the video in a minute. But you're looking at wide application are basically in high pressure gas cylinders, most liquid nitrogen, oxygen, argon, welding gases, specialty distribution, antibacterial environment for hospitals, medical centers, pharma, biotech industry, for EPA research lab also, and for seniors operating the medical oxygen gases. This is where this particular tool is used. You can see the area. This portion on the top that's for the cap. I'm sure most of you are familiar with that. This area with the pins coming out, that's to open up the wheel on the cylinder. This area is to mount the oxygen or nitrogen or CO2, the valve. And you can see this is for the welding gases. There are two other things for welding gases. There are holes there, which allows you to operate the welding gas cylinder too. This is called unidirectional, spark-free, antibacterial wrench. The brochure is here if anybody is interested in that. And this is what it looks like. You just saw that. And how do you play this? This is just, okay. This is a video on that, about 3 minutes or 4 minutes video.
Opening the cylinder valve is made easier by moving the ratchet into the wrench. One side of this unidirectional wrench is the ratchet disc with pins. Its special feature of being unidirectional ensures that the cylinder stem cannot be damaged by excessive torque if it was to be used for closing. As demonstrated here, the recommended method is to recess the ends of the tool into the grooves of the cylinder valve stem wheel and gently apply the opening torque. This will open the valve. To close the cylinder valve, simply use the end. No excessive torque should be used under any circumstance. Excessive torque in opening the open valve can damage the ratchet of the wrench. This wrench ratchet feature is extremely important as most of the users of the lab, pharma, or biotech companies and or universities that face major problems in opening the cylinder valve. Most of the Sherwood compressed gas cylinder valves can be easily opened with this tool. The medical gas cylinder valves can also be easily opened or closed with a large hole on the attachment arm. As performed by the operator, the medical gas valve stem is inserted in the larger hole of the attachment and simply applies some torque and open or close the cylinder valve. As a note, the welding gas valve can be operated by using a smaller hole on the attachment arm. This feature allows the user to operate the welding gas cylinder valve. This tool allows the user to replace a number of tools that are used to operate compressed gas cylinders. It is available in different alloys. For antibacterial and smart-free, TSI recommends using a tool that is made of bronze wrench and bronze attachment. Please contact TSI and own this unique patented wrench with attachment and enjoy the benefits of its features, such as ease of operation, enhanced safety, and more. Quantity discounts for larger quantities can be discussed with the TSI representative. More capabilities and technology service suite can be found on their website at www.tsinc-us.com.
Okay, this was my last slide on that. I'm open for the questions. I hope on time. I'm okay on time. Okay, any question you guys have? Or Brian, you have any question? Oh, sorry, go ahead.
My question is, how widespread is the use of your tube oxygenator?
This too?
Yes, in either wastewater treatment plants or aquaculture here in the U.S.
In U.S., there are a number of companies who are using, large corporations are using it right now, biosolids, pulp mills, chemical companies, fish hatcheries in California, other areas, also in Tennessee areas. They have used that. I personally have worked on those areas myself. In Europe, it's a very widespread. There are companies everywhere they're using this because it has a significant benefit, as we saw about energy saving. When you saw the ease of operation in case of power outage, you don't have to worry about smell or BOD, COD, humidity. It works very good. It's still initial phase in US even after 15, 20 years because there are a lot of companies who make aerators and they already have aerators there. And our competition has also aerators with oxygen in there. And they're making big money. Why to waste that kind of money? One of the projects we looked at is about 30, 40, or $50 million project, putting several aerators and stuff like that. This doesn't cost anywhere close to that. And very easy to turn on and turn off and that kind of stuff. So it's coming. It's coming. You're going to see more and more of his use in the United States. Other questions?
Take a few questions from online.
The first question I got is, when using the biohose system, how does the technology reduce the electrical demand on the aerators?
When you use the biohose system, as we talked, there is no electricity needed because oxygen liquid form, when it goes through vaporization stage, it's about 600 times more. So you already have now, you can decide if you put the liquid tank at 200 pound or 300 pound pressure, that's what the liquid nitrogen oxygen tank is. When you vaporize it, now you have pressurized gas available. You don't need that kind of pressure in the basin. Even if you put low level, this biosource does not need that kind of pressure. So without any electricity, you can easily inject oxygen into the system. So it basically eliminates the need for oxygen for aeration base. I hope that answers the question. Very good questions. I think we covered that part, but again, if you look at whenever you already have aeration basin, when you have aerators, that capital is installed in them, and then you have your quality of water stream, which is coming into the wastewater treatment plant. If that fluctuates, that means there's a more demand for oxygen. When you look at one of the slide, which was patent, where we show the basin, that's the first area where you're going to see a lot of organic material coming in there. The biological oxygen demand and COD is high, and you don't have enough oxygen in the basin. When you don't have oxygen, it makes anaerobic condition. So chemical called hydrogen sulfide is generated, and that's where the big smell comes. So you're going to see a lot of smell if you don't have sufficient oxygen. And I gave you an example of the wastewater treatment plant. Look at right near the residential area where the smell was very big. This was the very reason. Because when you look at the sources coming from, chemical plant or some other companies or household and all those things coming, it fluctuates. And if you are not prepared to provide sufficient dissolved oxygen level in the basin area, you are going to smell big time. When you go to the the wastewater treatment plant, and if you smell that, remember this part. It's because you have anaerobic conditions. When you put sufficient oxygen, when we saw that pure oxygen gives you 5 times more oxygen in dissolved phase, right away it will be consumed by the organic material and the chemical reaction will take place. As long as you keep it positive dissolved oxygen level, you don't have to have 45 ppm, 1 or 2 or 5 ppm, the smell will go away. That was the example we saw in the East Coast. And once you have positive DO, when it goes downstream, now you have a stream going into further wastewater treatment plant where you have less requirement for dissolved oxygen because it's already there upstream. If it was negative, aeration basin will have to work very hard. And that's a typical thing what we see in the industry, that they will replace the aerators, they will put aerators with the oxygen injection system in the aerators and all that stuff. It's costly installation. If you put Biox hose in there, you don't have to worry about aerators because it allows you sufficient oxygen. And interesting part is to, depending on the depth, as you know, transfer process, concentration gradient. You have a very high concentration at the bottom and high, you have low concentration, oxygen will quickly travel and dissolve. And so you can see that very, very easily it disperses and you maintain the DO level what you need. You accomplish 2 things. One, you didn't need electricity to do that. Second thing, you don't need rotating part. And the second part, you met your desired level of oxygen, what you need, dissolved oxygen level. And the most critical part, VOC, volatile organics. You reduced your inert coming out of the wastewater. You will see the benefit of BS. People are required to use some kind of a system to capture that VOC. If you don't meet, they put a lot of air. When they put a lot of air, more VOC will come out because more turbulence, and theoretically, you can only dissolve so much oxygen given pressure and temperature. You're not going to do any magic there. So by putting more oxygen doesn't help. Simple example, I was working with a fermentation unit where guy was using 1,000 cubic feet per hour of oxygen in there in the pilot unit. And I was assigned to do the trial. We did with oxygen. And I said, air has 21% oxygen. So I will need only 200 cubic feet per hour of oxygen there. I don't need 1,000 cubic feet. The researchers around me said, Sudhir, it's not going to work. Bacteria are going to die. This is going to happen. I said, I'm running the show, right? Give me a chance. And when I did 200 cubic feet, in 5 minutes, they were shocked. Oxygen level from the bottom to top, it was about 20 feet long vessel in there. It was in short time, the DO level was very consistent. At the end, productivity for that fermentation process went up by 30%. The yield in the fermentation terminology is conversion of sugar into finished pharmaceutical product or biological product, that's the yield, went up by 10%. It is unheard in biotech industry and pharma industry. All that because we were able to get rid of inerts and increase the dissolved oxygen level, which is needed for organisms to survive. All you need is oxygen in organisms that allows them to convert sugar or glucose into desired product, depending on what organism you use. So you can see what happens there. And then oxygen really provides an excellent solution. It's a natural phenomena there. Any other questions, sir? It's wastewater treatment plant-based decision on that as to what they have and what are the consumption patterns. And I have to look at all the different parameters as to, how much BOD, COD are coming up, what's the wastewater rate they're coming in, how much VOC issues they have, what are the foul smells issues they have, DO level at different phases. All those can be combined, and electric cost. All those things combined, and we will also look at the maintenance cost and also other costs, operating costs, and all that stuff. Once we know that, we can tell that as you're going to see a significant impact on the cost. Where we have worked, the return on investment for these kind of stuff is less than 3 years. It's a very attractive deal to do. And question will come, how come Americans are not doing it? We are still hung up on system, and somebody made a comment, Europe is 5 years ahead of US. That was a comment then. No, I think it takes time for them to see that. And there are alternatives which are based on oxygen. Those alternatives still use a lot of electricity. I don't want to go into that because that's a competition, so I can't mention too much about it. Yes, sir.
Sudhir, I was wondering if you could comment on two aspects that I think are critical for why wastewater plants don't generally adopt pure oxygen. One is the cost for the oxygen. Mm-hmm. And so you're trading off the electricity costs versus the oxygen supply costs. So if you could comment on that trade-off and
sure,
that's advantageous. And then secondly, the reliability of a supply of oxygen at a certain cost. So they would have concern that they could buy it today, they might be able to get a 5-year contract, but that 20 years from now, they may or may not be able to get oxygen at the same price. And so how do you get around the potential for oxygen costs to go up?
It's a very good question. So, let me answer what I have seen and what I've experienced. Depending on oxygen requirement, you decide the mode of supply. You need liquid oxygen, you need on-site oxygen generation system, you need pipeline. And when you look at the pipeline, it's a 15-year contract they supply, but there's a fixed cost for some period of time. And you get the oxygen there. If you have liquid supply, you put the tank close to the use point, and you have ability to negotiate. There are enough competition in the market that you can negotiate the price and get the price. Important aspect as to cost aspect with the oxygen cost versus electric cost. Oxygen is not just offsetting electric cost. It's offsetting maintenance cost, offsetting operating cost. A lot of changes, you can see that. And when I made the comment about return on investment less than 3 years, it's a realistic numbers. So the only aspect is you're looking at the supply system. When you look at supply, depending on need, depending on location, as a matter of fact, it helps you to look around because air separation plants are built quite often in different places. And as time goes, more and more air separation units are built. If there's something closer to you, the major factor in oxygen cost is shipping cost, transportation cost. Manufacturing cost depends on electricity, what the air separation plant is using, and then liquefying. So if you have plant closer, then your transportation cost is less. So it's advantageous to the end user. So there, as I say, there are a number of companies who are making now putting air separation plants different places, and depends on the need. And the general way they build the air separation plant is they look at that major user of oxygen and nitrogen and argon. And if that justifies that, they will put the plant there. then they will make additional liquid products, oxygen, nitrogen, and then they will ship it. So within 250-mile radius of air separation plant, that's where you are very competitive. If you're further away from 50 miles from the plant, it's a little disadvantage for air separation plants. So from marketing point of view, they will build the plant closer to the use point, like steel mills and big chemical plants and things like that. And then they will produce enough products that they can sell within that region. And so probably it's a good question, but I think there are a lot of competition in the market. You can control the oxygen cost. I hope I answer your questions. Okay. Any other questions? Yes, sir.
And to talk, I understanding using oxygen for the wastewater treatment plant, you can control the odor because of oxidation mechanism. But based on mechanism, but I saw that the VOC. How do you think VOC will reduction? Because most of the compound, for the biodegradation from big molecular to small molecular, the VOC. Also because oxygen will carry over. So I saw the VOC will be increased, not decrease.
The VOC, which is coming out of the aeration basin, those are critical for EPA. You need certain VOC level. When you put a lot more air, a lot more inert, and more VOC will come out. That will be exposed to human, and that is not allowed. So you will see VOC in the liquid phase because there isn't anything coming out from there because the oxygen is 5 times less than total airflow. So you will continue there. As long as it doesn't come out, you're okay. Then COD, BOD will be affected with oxygen. And so that goes in the system. If you look at the EPA regulation, they have BOD requirement, COD requirement, and VOC coming out, not in the water. Does that answer your question? Because which is coming out, that's critical because it's exposed to human. Same hydrogen sulfide, which is in the basin, and VOC. Those are which are exposed to human health. That's where the regulations come into play. So when you reduce your inert velocity in the phase, then you don't have that much VOC coming out. Makes a big difference, big difference. And when you look at hydrogen sulfide, when you basically produced a higher DO level, and so hydrogen sulfide reaction doesn't happen because there's no anaerobic condition.
Yeah, hydrogen sulfide I understand
okay.
Because it controls order, because of the oxidation, the procedure, so
right.
Less the hydrogen sulfide, the production, also the order reduction, But
yep.
For the VOC, because yep. From the because of biodegradation, not the big molecular, small molecular. So suppose the VOC will be increased. So this my question is, do somebody or do some this VOC test?
Yeah, they do it, and if you look at the requirement is before you move that water away to the river or something like that, they will check total suspended solid. They will look at COD, look at BOD. That's what they basically look at that. And VOC is only concern is out. And I know that number wastewater treatment plant, they're asked to close the thing or do something with the aerators because anything that's health hazard, that's what EPA is worried about. And this one will be in your favor because you don't have how much VOC coming out. I hope that answers your question. Any other questions, sir? Anybody else? Anything you have? Okay. Well, I'm good timing for me.
Okay, let's thank Sudhir again.
Thank you.